Hey, what's up guys? My name is Cherno. Welcome back to another Cherno live stream. It is the 18th of June today. I thought I'd start saying the date at the beginning so it's a bit easier to follow. Although obviously when they get uploaded to YouTube, the date will be in the title. But nevertheless, here we are on the 18th of June. We're halfway through June basically. I do really want to get this done by the end of the month. As I was saying earlier, we're going to wrap up this project by the end of the financial year, shall we say. Yeah, we've got a lot of work ahead of ourselves. I'm probably going to do another stream on Friday, but I'm not going to be working on this, most likely. So keep your eye out for that. I will add it to the schedule as soon as I confirm it. Probably going to be working on, yeah, some other projects, but also in Hazel. So we'll see. Okay, anyway, yeah, let's kind of recap a little bit of where we are at. Obviously, we are working on the new renderer, and we have it more or less up and running with all of the UI, and now we're moving on to the meaty stuff, the actual getting Hazel's 3D renderer ported over to use NVRHI, and also thinking a little bit about the design as we go through this, because one of the things that I really want to do with one of my big goals with this new renderer is also to not just port everything one-to-one to NVRHI, but start making some you know, now that we've used Hazel for a little bit and I've got like the idea of the design and what I want the design to look like for a quote-unquote simple game engine, simple and straightforward game engine, I would like to, and we've actually used it in practice. We've shipped a few games, you know, just game jam, little game jam games, but still, like, we've actually used it. I know like what the expected behavior of the engine probably should be, and what the more common, we'll say, not most common, maybe the more common, the more probable use case would be for like how the rendering is put together. I can start to make some tweaks, you know, to the renderer design, specifically like resource management, because that's a big part of any renderer. And by that I mean like, you know, the existing descriptor set manager that we have inside here. So we have this class called descriptor set manager, which is basically just a wrapper around Vulkan descriptors, but the idea is that this is used by both render passes and materials in order to be able to actually take inputs and outputs to either render passes or the actual inputs to a material, right? So this is the current abstraction that we have for that, which I wrote for Renderer 2023, which was Hazel's second generation renderer probably. And now we're on Renderer 2025, which is like the third generation renderer. I've disabled a lot of this stuff so that it doesn't compile, because it won't compile at the moment since we made so many breaking changes as part of this refactor, as part of this rewrite. But yeah, so this is basically the biggest, I don't want to say like bottleneck, but the biggest like consideration of this new renderer is not just like, let's blindly make everything work with NVRHI. It's also like, how do we potentially reimagine this to be a little bit more straightforward, a little bit leaner, and a little bit more suited, because it's quite flexible right now. And it also, I don't know, there's like some comments here that I probably need to read, and it's a decent amount of code here. So this is going to be probably something we do towards the end. On the other hand though, I don't know if we'll be able to get anything up and running before we fix this class and we get this class kind of up, like working, because this is the way that we bind any kind of resource to a Hazel render pass or to a Hazel material, which is obviously used to render meshes within a render pass. All right, Salim says, hey Cherno, blah, 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 Egypt to stay the last month, keeping in the end of the series. I'm wondering if I complete all the series in live stream, what the final product I will ship. So, I mean, the game engine series kind of ends on us trying to make a game with it. And we basically have C# scripting. We have like a 2D editor, you know, that's capable of 2D rendering. We have an entity component system, so you can kind of, there's still a bit more work you would need to do on your own to piece together something that you could say ship, but at the very least it should give you all the building blocks, all the major systems and the major building blocks, so that you can actually build something. But the intention there is very much like, hey, here's like 100+ episodes of how to make a game engine, how to make a simple kind of 2D game engine, and then from there it's up to you to, hopefully you've learned enough as part of playing around on your own, reading stuff, and obviously following the series to then take that further on your own accord. So that's basically where I left it. I don't know if I'll look like in the distant future. I wouldn't be opposed to making obviously more like deep educational series content like that. I just don't think it's very suited for YouTube, as I've mentioned before, because YouTube is like, you know, the first couple episodes do great and then everything just falls off. And so it's basically like, it's not going to get too many views and it's not going to get too many sponsors or brand deals that are going to, like brands that are going to be happy to sponsor those kinds of videos, because that not only do they not get many views, but then also they get recurring viewers very strongly, right? So one-off videos always do much better on YouTube. So that's one of the reasons why that series had to eventually end. I mean, doing over 100 episodes is quite a lot for a series, and it was rather popular back in the day, but yeah, that's why it met its demise, an unfortunate end, because, you know, life is life, business is business, it is what it is. Which is why I kind of have the dream. No, I'm talking about the game engine series. The C++ series still, like the C++ series is effectively one-off videos, right? So those I still make. I haven't made one in a while, but I've got like a list, and I'm probably gonna try and make one next month, July. But yeah, but in terms of like, you know, if I ever make deep educational series again, like a game engine series or even a new C++ series, I think I'll just like, it'll just be a course. I really want to make like a course platform that's like my own kind of, not like, you know, Udemy or whatever, but just like my own course platform with like a lot of educational content on programming and game engines. And then obviously that will be paid, but I'll try and keep the price, you know, not that much. And obviously the course will be complete when you pay for it. So you have all the like 50 hours plus of content or whatever might go into a course. And then, you know, it'll be much more professional because I'll be able to invest some time and money into producing it properly and making sure that it's good. Whereas YouTube's kind of like, when I started the C++ series on YouTube, it was very much like a hobby. I wasn't really making money from it in the beginning. Well, not more than like a couple $100 a month anyway, just from YouTube ads. Okay, anyway, we've got doing a lot of like meta discussion here and stuff. Let's go back into yeah, and also one more thing I'll say about the courses and stuff. I feel like I haven't done it yet because I'm so busy with existing work, and obviously we want to ship Hazel, but I feel like it'll be a good thing to do once we ship Hazel, because once we've shipped Hazel and it's free, then obviously I can kind of be like, hey, you know, yes, I worked as a game engine programmer at EA, but I also built this thing on my own, kind of, well, with a team, but like, you know what I mean? I directed this. So like, therefore, you know, that's some credibility for why you should buy my course. And and yeah, it's nice to have achieved something, even though of course I was a professional engineer and all that, but it's nice to have achieved something, you know, before actually, but also it's nice because it's not even just the credibility argument, it's also the fact that since I have actually made this game engine, I now firsthand have all that experience, so I can probably teach it more effectively. Whereas if I just work at EA, it's like, well, I didn't build the engine. I help build the engine, but I'm working on such a small part of it that, like, you know, do I know what I'm doing? No, but with Hazel, I can be like, yeah, I know what I'm doing. Okay, can I ask an irrelevant question? Yes, quickly. Yeah, we'll do like a little bit of a Q&A. I'm gonna organize my thoughts here anyway, and if you guys have questions, then ask them quickly. If you were to build a game from scratch as a hobby, would build an engine and game application side by side, or would you blur the lines and kind of build it as a monolith, assuming Hazel didn't exist? Ooh, look, that's a tough question for me personally to answer, because I think I enjoy game engines more than games, so I would probably be tempted to make it as an engine. I think that, like, if there was a very finite scope on this, so like I had a year or 2 years to just build this single game, and for whatever reason I would not ever foresee myself reusing that technology. So it's like some company came in, dumped a bunch of money on me and just said, build this game exactly, and that's it. And then also you don't own the code, so therefore you can't reuse it later. It has to be just for this, we own it, but we've paid you for it. Then I think, yeah, I mean, it would make more sense to just build the game. I would still build systems, like I would still build, like the game and the engine could be one, but there'd obviously still be the idea of, like, you know, separating concerns and having systems take in somewhat generic data where appropriate. And that's not because I want to reuse that in future projects. That's just because the game itself might want to use certain systems in different ways for different parts of the game, right? So like, for example, writing a renderer, like you'd probably separate a renderer from concepts such as the entity component system. Like you don't have to, but it makes sense to, because the renderer wants a very different view of data usually than this like entity hierarchy and all of that stuff. It doesn't care about anything like that, right? So there's still like gonna be that distinction, but in terms of like making a separate application that's like this versus that, like maybe yes or no, it depends on the game, but like it doesn't have to be that. Happy late Father's Day. Thank you. It's Father's Day in Australia is different to Father's Day in the US. It's the 7th of September for us. So I will remember you though when I celebrate Father's Day on the 7th of September. Does Hazel have any input context routing, or does it just rely on the IMGUI window focus for determining that? Yeah, yes and no. So just trying to think. Effectively yes, but I don't think it's as automatic as you might think. Because basically, panels, panels obviously can accept input, as can the viewport, but we have a layer system that receives events, and that layer system, with its event system can consume input events. So it can be like, I am the topmost layer. I'm taking that event and I'm not propagating it to the layers further down, which might be like the game layer beneath the UI layer, for example. But in the editor, we have a viewport, and games that are obviously written in C# in Hazel can actually do things like lock the mouse. And so obviously if it like locks the mouse to the viewport in C# while you're playing the game in the editor, it's locked. And like it's up to the game to add like escape to unlock the mouse, for example. But otherwise it'll lock the mouse, it'll hide the mouse cursor. For example, if you're making a first person game and you obviously want to move the camera with just by moving the mouse. So yeah, like there's, in terms of like inputs and stuff like that, yeah, you can do that. I think Salim's trying to post a message, but it keeps smart detection keeps blocking it, so I'll allow it. I will catch next code review, so I have code that's on mine since 2003, and engine and client, also server. Will send it for you. Please make a YouTube video. Yeah, I'll see what I can do. We'll see how interesting it is. Do you use raw input on Windows? We looked at that at some point, and I think GLFW supports raw input to an extent. I actually don't know, to be honest. I remember a discussion about it years ago. But I think GLFW, if we just have a look at GLFW, Win32, would it even be in Win32? Probably, right? It was probably in Win32 window. Yeah, so like here's H raw input. So GLFW, yeah, get raw input data. So GLFW handles it. Whether or not we use it is, yeah, so see, you can set raw mouse motion to true, and if you do, then it's gonna get raw input data, but it will still set it to the input cursor position. Whereas if raw mouse motion is set to false, which it might be by default, then you don't do this. So yeah, possibly. If not, then it'd be easy to add because the backend supports it. All right, cool. Anyway, thanks guys for all the questions. Good chat. I'll still keep keeping my eye out on them, but I want to start getting some work done because we've got a lot of exciting work to do. Because basically what we ended up with storage buffers last time. So what we're doing at the moment is we've got the we've got with the new renderer, we've got the main editor running and we've got all the UI for that via IMGUI, which we've now updated to the latest version as well, which is great. We've got all of that running, and now we are going through the scene renderer, which is Hazel's high-level renderer, which renders the scene, right? You give it the input of a scene, and it outputs an image for you. So that kind of level. We're going through and we're making sure that all of the like renderer resources and concepts like render passes, everything actually is ported over to NVRHI / the new renderer. So we went through this, and like towards the end of last stream, I think pretty much at the very end of last stream, we went through all these uniform buffer sets. So uniform buffer sets are sets of uniform buffers, as you might expect from the name, and basically it's a collection of 1 to 3, usually, uniform buffers, because if you have multiple frames in flight, then you may need multiple uniform buffers so that you can write to one while reading from the other. And obviously, because if you have 3 frames in flight, the CPU is allowed to get 3 frames ahead of the renderer. You have to have 3 of them. So that's basically, uniform buffer set is just a way to abstract that, and basically everything in Hazel can either take in a single uniform buffer or a uniform buffer set. And if it takes in the latter, then it will basically ask what the current frame is and use that specific index of a uniform buffer. So that's uniform buffer sets. And similarly to that, we also have storage buffer sets where required. So for things like visible point light indices, you would need that. Obviously, if it's like static data, you don't need like sets of storage buffers or uniform buffers. It's only for data that's written to every frame, basically, because that obviously allows concurrent writing / reading by the different devices, by the CPU, by the GPU, and also allows the CPU to get 2 frames ahead instead of 1 frame ahead, if you have 3 instead of 2. So that's why it's kind of triple buffered in a way. So that's great. So yeah, now we are really onto, and then obviously materials we need to patch in, because as I mentioned, materials they use this descriptor set manager, right? I think I don't actually see it here. Oh, that's because it's in Vulkan material, which I excluded. So yeah, they do use the descriptor set manager under the hood, which is something that we now need to change. And I think, yeah, this does nothing at the moment. So obviously materials are dead, and we have to basically rewrite. Oh, no, my battery died. That's weird. All right, hold on, guys. How does that happen? Maybe I didn't. Maybe I didn't plug it in properly. I thought I saw it plugged in though. That's very strange. Yeah, it does say that it's plugged in. That is annoying. Okay, I'm kind of back, but it might shut off again. That's very weird. Maybe it's not getting enough power. Yeah. All right, face cam's gonna be off for a bit. Sorry, guys. It's very strange. I should probably get a more powerful charger, but that doesn't make sense because give me a sec. Yeah, that's very strange. All right, whatever. Yeah, I guess I just didn't have it charged or something ahead of time. But I don't understand. It usually doesn't draw more power than it uses to charge, but I'm using a slightly different system. Okay, I'm gonna try plugging in a much more powerful charger with a higher wattage. In the hopes that that will work. So I'll give it like 5 minutes to charge up and then I'll turn it on. Yeah, the USB power seems to be usually all right. Like, as in, I've been streaming for years with it, but I'm going through like a battery now. So there's like a V-mount battery that plugs in via USB, and maybe that's delivering less power than a direct line. So we'll see. But yeah, usually I haven't had any issues with it, so it's a bit strange. But maybe it just loses power, but at a very slow rate with that second method. All right, anyway, yeah, so now we're going through the storage buffer sets because we need to refactor that as well. Yeah, so this stuff I think also was for some reason written as like like we had a specific Vulkan storage buffer set, even though this is completely generic because it just wraps storage buffers, which I don't even know where they are. Like, where are the storage buffers? M storage buffers. Oh, here they are, yes. So you can see it wraps storage buffer, not Vulkan storage buffer or anything. And it doesn't do anything Vulkan specific. So it's a bit strange. So what we'll do is we'll kind of reduce this back to being not a... this doesn't matter too much. But anyway, not a subclass of storage buffer, so that we can basically keep this code compiling for no reason at all other than it's easier than removing it. And then we'll grab basically this entire class and paste it here minus the create function and maybe the destructor. So I'll put the destructor and the constructor down here because you're not really supposed to use them, but we still have to keep them public for reasons. And then I don't know if I should make it explicit. Why would it be explicit? It's got so many parameters. Anyway, whatever. So we'll do storage buffer set, and then I'll move this to the CBP file. But yeah, that's basically it. Everything's good. Oh yeah, the constructor. So the constructor will move down here, and we'll implement it elsewhere because the correct way to make it is via this create function. Cool. And then that looks pretty good. So we'll just return ref. It's a very long line, unfortunately. Okay, I'm gonna try and turn the camera on. I'm gonna see what happens. Yeah, all right. We'll see. We'll see. We'll see how long this lasts. It's not flashing anymore though, which is good. But it might heat up more. So we'll do ref create over here. Sorry, I know you guys can't see that. It's a very long line. Should probably change it. And then I need to pass in. Yeah, I think I will change it. This is a bit ridiculous. Okay, so this is, how long is that line? 210. What do you guys think? 216. Too long? I guess we can just do that. Or something, I don't know. Do you have a video of yours you can point to for clean API for Vertex data? Right now, I just assume you have a position normal UV. Clean API for Vertex data. I don't really know what you mean by that. Like an API for defining the layout of Vertex buffer or Vertex buffers. Because we do it like this in Hazel. So like here's like our normal standard 3D Vertex layout. So we've got these attributes and here are the types. And then we have for instance rendering, which we use basically all the time, we have this. And then for bones, we have this. So we have 3 different vertex buffers that are bound to main geometry passes. But this is kind of how I think I did have an OpenGL video that created something similar to this. So vertex buffer layout is a class that basically has a vector. I don't know if it should be a vector. Maybe it should be a static vector. But anyway, a vector of vertex buffer elements. And then they have all of these things. And then the idea is you can just add them like this because it takes in an initializer list, and then it will calculate all the offsets and the stride and everything for you so that you can then just use this vertex layout. It's used as like, you know, a layout in the pipeline specification, and then that finally means that inside when we create the pipeline, the vertex layout, it can then iterate through the vertex layout. In this case, we have the three that I mentioned: vertex layout, instance layout, and bone influence layout, if they're set, because otherwise these would be empty. If it was a render pass that was more simple, or a pipeline that's more simple, didn't have it. And then obviously fill in like in this case, they're NVRHI now attribute descriptions, otherwise they'd be Vulkan attribute descriptions with all the details and create the input layout and everything. So that's how it works. But I think I did make a video talking about how to write a quick class like this. Obviously it just makes it a bit easier because you don't have to worry about, like, all the strides and the offsets are calculated automatically. And then all you have to do is just lay it out nicely like this. And the name isn't that required. DirectX will want some kind of name, most likely. That's why I think in the new kind of system, yeah, so we're gonna have to check that out as well. Well, for HLSL, I don't know if GLSL will care. DirectX with a GLSL. DirectX with GLSL though will it'll have to port the shade. It'll have to SPERV cross the shader into HLSL first, because at the moment the SPERV compiler can't generate DirectX bytecode. So actually we'll have to tweak that for DirectX, but we're trying to get Vulkan working first anyway. And then obviously we'll get DirectX 11 and 12 working as well. But that being said, what was I gonna do? Yeah, I was gonna look at IMGUI renderer, because that I think is an example of us actually setting the correct kind of names for DirectX. Where would that be? In it. Yeah, so you can see that like the vertex attribute layout that they have actually manually calculates stuff. This is part of NVRHI, and then position, text, chord, and color are actually kind of written in a special way because they mean things in HLSL and DirectX. Do you do M specifically for maps? No, M underscore is for member variables. So I actually made a video about this. So for private member variables, I do M underscore. For static, you know, I'll do S underscore like here. If you have a look at, I think, naming conventions in C++ is the name of the video on YouTube. I explain why and what the deal is with that. And you can't miss it because the thumbnail is like M underscore what or Y or something. All right. Someone asked a question, I think, earlier about NVRHI. Can you explain? Yeah, Moosey boy. Sorry for getting back to you so late, but can you explain like I'm 5 NVRHI in the context of Hazel? What does it offer compared to the previous setup? It basically just, all it does is it abstracts the backends, right? So the renderer backends, so the render APIs like Vulkan and DirectX. Because at the moment, like Hazel once upon a time supported both OpenGL and Vulkan, and I wrote that entirely, that whole backend, that whole system of supporting multiple render APIs. Then we decided to drop OpenGL because there was really no reason to support it. And now we're in a position where like it would be nice to support more render APIs going forward. And you know, DirectX 12 might be a good example of something we might want, you know, to ship games on Windows, because it's a little bit better suited to that. It's a bit more native. And then for like, you know, Mac OS in the future, we might want Metal. You know, if we do like consoles in the future, we also want to be able to write like a backend for that. So having like a good abstraction, something called a rendering hardware interface layer, so an RHI, that basically doesn't actually implement any kind of high level rendering, but it just means that, you know, instead of having to specifically write Vulkan code to say create your pipeline, you instead use the abstraction layer on top of that, and then it will map all of these things to the relevant render API for you. So you're still doing all of the work basically, right? You can still see I'm still doing all of the work to actually like create this graphics pipeline. It's just not Vulkan specific. And of course I could have written an abstraction layer like this myself, but NVRHI already existed. It's written by NVIDIA. It's been out for a while. It's supported by them. It's maintained. It's actively in development. It has nothing to do with only supporting NVIDIA GPUs, of course. It just uses Vulkan and DirectX 11 and DirectX 12. Yeah, but also it comes with some nice features like automatic like state tracking for resources, so that I don't have to, like, it basically has a system for, you know, like, what are they called? I was going to say like image memory barriers and stuff like that, but for like synchronization and for making sure that like your resources are in the right state, you know, when you're writing versus reading them, and doing all the state transitions, the state tracking for you. So, and it also does resource garbage collection and stuff like that. We already had that in Hazel, but anyway, it gives you like some nice features. So it does have some stuff on top of just the render abstraction, but yeah, and obviously it works with DirectX 11, 12, and Vulkan, and in the future I can add a backend for Metal, for example, if I want to. So, yeah, like that's why we use it, because it's going to simplify our rendering code a bit, and it's also going to give us more APIs. Okay. All right, cool. Let's get back to storage buffer sets. Yeah, so what I want to do is move all of this stuff to here. We don't need this anymore. Why is this? Let's just try compile it. Render is not a class, apparently. Oh, right, and I already have definitions for everything. I forgot to remove them. Put resize up the top. Okay. And then what else did I want to do? Yeah, just put resize up the top. Okay, so what else does this need or want? Why, oh. Yeah, I'm supposed to do that. I did the same thing for uniform buffer sets. I don't know how I ended up copying the wrong thing. Just compile that real quick. All right, redefinition. Yeah, I remember that. Where is it? Here it is. Okay, cool. So we've got that working. Again, the Vulkan one we can delete now basically. So Vulkan storage buffer set. And we also had Vulkan uniform buffer set, which already were deleted, so that can just, yeah, be deleted now. Okay, cool. So that's storage buffer sets done, and obviously they just map to storage buffers, which are these things here, which they, if we look at them, oh, they're not done yet. Did we do uniform buffers? Yes, so uniform buffers are done, and we just basically need to give the same treatment to storage buffers. So storage buffers also used to be, there used to be a Vulkan storage buffer, and then that obviously did all of the Vulkan-specific code, as you can see, for storage buffers, like this. So the good news is they're basically, I don't think they're really any different from uniform buffers, are they? I mean, this looks slightly different. Because it might be GPU only. We have, oh, right, because also the other thing is we have staging. We want to make the memory GPU only. So we have GPU only in the spec because that just greatly speeds things up if we just want to store a bunch of data. Well, it's not even storing a bunch of data. It's like, for example, the light culling system. Like it will, the compute shaders will write into storage buffers and the CPU never writes anything into there. So having it not be GPU only memory is just silly. Like it's just a What's the opposite of what's the opposite of an optimization? It's just it's not like, it doesn't make any sense. Like you would want to have that GPU only, but obviously in case you want to set data or whatever, you then need staging for it. I don't know if we necessarily need this though, because obviously if it's GPU only, you don't need staging. It's only if you want to set data from the CPU to the GPU and it's in GPU only memory, then you need to have that intermediate step. But you can see actually that no staging seems to be defined. So we don't probably need this actually. We can just do this because I'm guessing it, yeah, I think we just made a generalization that if it's set to GPU only, then you can't set data, even though there is a way to do that, which is this, but I don't know, whatever. So that's good. That makes this a bit easier. So the only thing we need to worry about is this GPU only thing. That's the only difference between a uniform buffer, which obviously is not GPU only, and we just need to make sure the memory usage is set to GPU only versus CPU to GPU. But I don't know how NVRHI deals with that. We're going to find out, so that'll be fun. So what I'll actually start by doing is, well, yeah, let's go back here. We'll keep the specification. We need to keep this API obviously the same. Create, we're going to put up the top. We're going to make this another public section here and a private section as well. And then let's get rid of these pure virtual things. And then we're going to drop this down here, and then we're going to need a constructor, but we might take that from Vulkan storage buffer. Yeah, and then the other stuff we'll think about later. So we'll just make that constructor here. And then we've got the create function and everything. Don't need this anymore. Render row we might need. And then if we have a look at the way we implemented uniform buffer, well, actually, the functions we've already got actually. So let's just create method implementations for all of these things except for create, because we can do that over here. I don't know where to tab this to, but anyway. Ref, storage buffer, create, size. So that will go to the constructor. Why do we have size and then the specification? This is bizarre. Like, should that be part of the specification? I don't know. Whatever. We'll keep the API as is for now. We might make it more consistent in the future. Okay, so this is the constructor. Let's put that first. So if we have a look at, so let's have a look at Vulkan storage buffer. Oh wow, we got so much stuff here. Do we need any of this really? I don't know. Oh, yeah, we've got a lot of stuff here. So the spec we want and the size we want, and I guess the name, that can be like a debug name. That we don't need. Yeah, let's call this debug name. Well, actually that's in the spec, so we don't need that. Okay, so we'll set the size and the spec. And then we'll basically do what we did in uniform buffer. Local data, I'm gonna not do for now, because a uniform buffer is very commonly you're going from CPU, you're putting data from the CPU to the GPU, right? But with storage buffers, like, I don't actually know if we ever stream in data from the CPU. We actually might for animation now that I think about it. Anyway, I'm sure it's easy to tell because we can just see if SetData is being called ever. And in fact, I can put a breakpoint in a working version of Hazel to see that. All right, anyway, let's paste this in. So is constant buffer. So there's, I think there's a is. Oh, good. There's a CPU access mode, which I guess we can set to none, and that will map to GPU only maybe. And then is set is. Yeah, I want to see how this maps to a storage buffer, right? So I don't really know. So if we have a look at this, the reason it's a storage buffer is because it has VK buffer usage storage buffer bit, right? So if we copy this and I go to Vulkan buffer inside NVRHI, I can search for this presumably. It's probably not in buffer though. It'll be in, Let's search for that in current project, and we'll find the mapping hopefully, or not. That's annoying. Let's see where create buffer is. Oh, right. It's using the Vulkan HPP, so it's a bit different. It's this one, right? So basically, it gets the storage buffer flag if can have UAVs. So unordered access is true, or raw views is true. And then if it's typed and can have UAVs as storage text cell, which makes sense. Can have typed views, but just get normal text cell. So this is good. Obviously, this is useful. Indirect buffers, this is going to be important as well for the GPU particle system, but we don't actually have that inside merged in yet. So yeah, so to be a storage buffer, it has to, so can have UAVs is basically, I don't know, can have raw views if there's any, what's the difference? Or maybe that's more for DirectX. But I guess I'll do both. So instead of set, apparently it's can, but that's not even here. It's, oh, set can, yeah, okay. So then instead of set is constant buffer, which is a uniform buffer, we can do that can have raw views and can have UAVs. The initial state we can set, can we set that to storage buffer or UAV, unordered access? That's probably what the initial state should be, I'm guessing. What else? No, that's it. I don't know if yeah, I don't know. I'm guessing that's the equivalent. Have you ever tried building and running Hazel using the MinGW environments? If yes, how to performance we haven't done any performance benchmarks, but we do build Hazel using Clang on Linux because we support Linux. So I don't know if we've tried Clang on Windows, for example, or you know, GCC, G++ on Windows. Oh, well, actually, so GCC/G++ doesn't work. Like, it won't build Hazel because it's very strict with certain things. Like, for example, you can't have variables that are the same as class names, right? So one thing we do often, which we definitely should stop doing, is, I don't know if I'll find it for you now, but well, this is this is kind of an example, but you see how in this struct, like, we've got ref texture2d texture, and this is a class name. Like, there's a class called texture because texture2d, you can see, is a subclass of texture. So that's a class name. So GCC, G++, GCC, G++, same thing. GCC is the C compiler, G++ is the C++ compiler. But basically, that does not support this. Like, so this will be a compile error. Whereas Clang and MSVC are fine with it. So because of that, I kind of gave up trying to get, because I was on Linux once upon a time and I was like, maybe we should try G++. And then I was like, no, there's like a billion errors and it's going to take a lot to fix. So it's bad that we do this, obviously, and we probably want to do a pass over this at some point in our lives. But at the moment, we support MSVC and Clang. And it compiles in both, although I haven't tried Clang on Windows, and I certainly haven't done any performance benchmarks. So yeah, but you know, I feel like, because I don't really care too much about that stuff, right? Like, when we get to the stage of like shipping games and stuff like that, right, then obviously performance is very important. And like, at that point, I probably would be like, let's do this in all the compilers. Let's see if we spot anything that can optimize or we can fix or whatever, right? But for a game engine, I'm less concerned. It might sound weird, but I'm less concerned with the performance because obviously I still want the runtime to perform really well and the game engine itself should perform really well, but I'm not going to that level of optimization because to me, like, the game engine isn't, Like, a game has to run fast because if it doesn't, it ruins the actual gameplay immersion and experience for the player, right? That's why it's so important, because it's like you've got an art piece and it's not functioning correctly. That's really bad. But a game engine is a tool. So if it's like dropping frames here and there in the editor, it's like, well, I don't care at all. Like, yes, it's not ideal, but it's not breaking the immersion for me. Like, yeah, it might annoy me in my productivity and my workflow, but that's a different story to someone experiencing your work of art, which is a video game, right? So that's why it's also important to kind of consider that, which is why I'm not at this stage, because I'm like, I don't even have a game, you know, to kind of, yeah, to work with. So, so for now, no, but yes, in the future, I would like to explore more compilers and obviously make sure that we can actually compile on all three major ones. Okay, so handle we'll need. And yeah, I mean, that should, so we call this storage buffer. We really should set the debug name to mspecification.debugname. And let me actually make sure that we do the same thing. You see, uniform buffers don't have a specification somehow, and they don't have a debug name, which is really weird. I mean, sure, they cannot have a specification, but I'm gonna add, let's do, yeah, we will do string view in here. But then we'll store it as a normal string, obviously. So std string debug name. Oh, I kind of want to take these in like so. Then we can have the handle on that. Drop this down because I've started doing that. And then adding in a string view debug name. Oh, by the way, I guess you don't have to specify this, so we'll just make this uniform buffer by default. And then, I guess in case anyone uses the constructor, I'll add it to the constructor as well. I mean the default argument part of it. And then we'll just make sure that we set it. And then we'll use it obviously here. Yeah, I mean, to be honest, we don't, I mean, I'd like to store it, but we don't have to store it because it's stored here, but I will anyway. We'll store it as an std string. Okay, cool. So that's good. That's better. We've got the ability to name that now. And I guess for storage buffers, we can kind of do the same thing. Instead of having a blank debug name, let's have storage buffer as the debug name. That way we can easily see things. Okay. So next up then. Okay. So 6 years of game engine, still full set of hair. Yeah, I think that I am quite blessed with my hair genes because, but see the thing is, so my mum had great hair and then she kind of is not doing so well with the hair these days. So, and that hit her around like 50, 45, 50. So I'm like 30 now. So, and my hair is more like my mom's than my dad's. So I really hope that, you know, I'm going to be like this when I'm 50, but who knows? Who knows? By then, maybe they'll have better technology for maintaining hair. All right. Cool. So I mean, this is kind of it, like for most of it. Like obviously we need SetData and I guess resize, but like we don't really need that stuff. We don't even have resize and uniform buffer. Well, yeah, actually resize is going to be super important for storage buffers. But the way we would do that is probably just recreate the storage buffer, right? So, we might want to store the buffer description and then just like reset the byte size and then create it. How do we do it in storage buffer? Like what did resize do? Oh yeah, we just had invalidate. which released it. And the render thread. We aren't going to do it on the render thread though. That's stupid, I think. Okay, let's do this. Let's invalidate. So basically, people ask me sometimes what on earth invalidate means and why I use that terminology instead of create buffer or init. Basically, invalidate just means that like something has happened, more or less, to make the specification, you know, which kind of includes the size here, not match what has actually been created on the GPU, for example, since this is a resource. And so effectively what it means is I would like you to basically make it good. So since the spec has changed and we need to invalidate the current state of, we have invalidated the state of it. In this case, it would mean recreate the buffer, basically. Recreate the buffer with the current spec to make sure that it is valid. That's what it means. So typically you would call it, for example, when you resize. So in this case, all we would do is we would set the size to be the new size, right? I'm not gonna call this new size. I'll just call it size. Yeah. And then we invalidate it because obviously we've changed the specification of the buffer. So we need to invalidate it because it now needs to make it good again. Now with this buffer description, I think what I'll do is I'll retain it. So we'll have like buffer desk, I'll call it. And that way we'll set it here and we won't do any of this. We'll do that in invalidate. And we'll obviously do that here. But the idea is when we actually update the size, we can also set byte size to size, right? So we're updating it in the description. And then when we do invalidate, it will actually do that. Now, it does beg the question of if we are storing the spec, why are we storing the size? And to be honest, we don't need to. So I'm not going to store the size anymore because that's something that we store inside the buffer description now that it's not a local variable and we store it inside here. Okay, so yeah, so all we do is we update the byte size, the spec has changed, so we invalidate it, and that will make it valid. Hope that makes sense. Okay, so SetData and RT SetData. All right, so, oh yeah, the other thing I was gonna do is, so that GPU only thing, right? So set CPU access. So if the specification GPU only is true, then I've never done this before in NVRHI, so I don't actually know if this is what I think it is, but we'll check in a minute actually. So none. Otherwise, I'm guessing it will be read write or something. Now read write though is that it must not be that because you can only set it to one of these. So maybe I'm wrong. Yeah, let me see what this does, right? So this CPU access situation, what does that do? So if it's volatile, we get CPU access, right? That's for copying. Oh, okay, here we go. So when we do map buffer, then it will set the access flags to either read or write based on the, but that's CPU access mode here. Buffer description, CPU doesn't equal write. Then we do that. What's this write buffer? I'm interested in how it decides. I guess it might decide to set the memory type based on the actual usage rather than explicitly like that. Because if it's like this, well, but we'll see, I guess. I don't know. Let's see when it does the actual allocation. So allocate buffer memory. Don't really see any memory types here. That is odd. Oh, well, here it is. Oh, no, it's just naming the device memory. Yeah, buffer memory. Where's buffer memory? Well, to get the right memory type allocated, and it sets this to right, so that must have something to do with it. But what I'm trying to figure out is, allocate buffer memory. Vulkan allocator. So it must do it here. Shared resource flags. Okay, that's fine. Get memory requirements. Yeah, I don't know. Pick. Here it is. Pick buffer memory properties. So it does do it based on the CPU access mode. So if it's none, then it's device local. This is what I was looking for. So device local is GPU only, because device means GPU, host means CPU. So device local is GPU only, so we do in fact have to set our CPU access mode to none, which I believe might be the default anyway. But if we want it to be host visible, then we have to set it to write. So otherwise, if it's a read, it's host visible and cached. So that seems pretty fine. So I wonder if we have to do that for uniform buffers then. But then again, we do set them to constant buffers, so surely, you know, that would mean that. But it doesn't seem to. It seems like it just looks at that. And the default, let's see what the default is actually. The default is none. So I guess we should set, I don't know, we'll have to verify when we actually run this, I guess, because I don't want to spend ages reading everything. But we would have to set this to write. Because we're going to be writing to it every frame. And then we don't really have to set this to none. Oh, well, actually, yeah, I guess we do, because we have to, if it's GPU only, we'll leave it at none. And if it's not, then we'll set it to, I guess we have to set it to write. But again, it's going to be GPU only. That's actually the default anyway. It's going to be GPU only for like most of the case. Okay, so SetData. Again, I just don't know if we ever do this. Like, okay, so no, that's the vertex buffer. Don't think we do that. So you know what? For now, I'm gonna be real lazy and just put a little verify false in there, which will basically be a runtime assert, even in release mode. That basically just you know, says that it's not implemented. But we'll come back to that. Okay. Just because I don't actually think we do that at the moment. I guess we should support it. But then again, I did just say that we might do it. Yeah, we do it, unfortunately. I knew we would do it in the animation system. So here it is. So we do it, where is it? Somewhere here, right? This is what it opened. I don't see SetData anywhere though. Oh, there it is. So you can see we do SBS, which means storage buffer set bone transforms. So we get the appropriate one for the current frame in flight, and then we set data to that. So this bone transforms storage buffer, which we create up here, has got to have the spec of GPU only false, which it does. So that would mean that we do in fact need to do write, and then we need to write. So set data, we'll just do render a submit, which means we also need local storage. Oh boy. All right. Actually, since we're doing this, let's duplicate these and have a version it takes in a Hazel buffer because that just keeps things a bit tidier, but we can have both. Except we'll do that here because this will just call SetData and wrap it in a buffer. And we'll do a similar thing here. Giving people some API flexibility, you know. All right, and then RT SetData is where everything happens. So what do I need to do here? Local data. So we'll call it local storage. And basically, if specification GPU only is false, then we'll allocate some storage. Getting and then if we resize, let's make invalidate do that because then it will reallocate. Do we have a realloc function or like something that will? I guess we do release and then. Why don't we do a little reallocate? It won't actually do a realloc. It's a bit of a lie, but what it will do is a release and an allocate. And then that way we can just, because release will do nothing, right? If, yeah, it will do nothing if there's no data, if it's null pointer. And that way we don't have to, we can just do reallocate. I mean, I guess in a way it's annoying because the size might not have changed if we do invalidate, but whatever. Okay, and we need to make sure we call invalidate here, by the way. Okay, so what we need to do here is basically copy the data. So whatever data we're setting, we have to do see, that's annoying because that does the allocation. That's static. I guess you do write instead of copy. Offset. Well, I guess we need to do that. Well, no, actually, offset is where you write to in the GPU buffer, typically. So yeah, so here we do instance local storage, because now we've copied into local storage. And yeah, we do need to pass an offset as to where to write to. Or maybe it will use both. I guess it should use both. I don't know, actually. What do we do for uniform buffers, for example? I mean, we just rewrote this, but oh, nice. Offset's not even used. Okay, let's have a look at what this used to be, because that's wrong. Actually, I can look at existing Hazel. That'll be better. So if we have a look at Vulkan uniform buffer, that's what I'd like to look at. So data plus offset. We map memory and we write it into data plus offset, but we don't offset the, yeah, because I guess we're the ones setting the data, so it's expected this is already, like, you want to start writing from zero. Why would you want to provide a block of data and be like, actually I want to start halfway through? You just adjust the pointer if you want to in that case. So yeah, that makes sense. That definitely makes sense. So for here, we should do, so write buffer, destination offset bytes. So that's what offset is. We just didn't, it was just an optional parameter, which we didn't specify. This needs to happen. I wonder why we need to full on do a command list for it though. That doesn't make sense, right? Can't we just set the data? Why do we have to write a command list? Oh, you know why? It might be because it needs to get it into the right state. Yeah, okay. We'll do that. We might have another look at it later. Okay, so RT set data. Why are you upset? Because it needs to be mutable. Because that's not a const function. And then this is basically what we'll do in set data. So yeah, I mean that compiles. So that's probably correct. Yeah, and then that should, because it's got this initial state, which we mark as keep, and it's unordered access, it should basically automatically transition it to a copy destination or transfer destination state, write the buffer, and then on closing it or whatever, it should return it back to this initial state. So that's that automatic state tracking I was talking about, which makes life a lot easier. Okay, good. So we've implemented that because of the animation system. So it is what it is. That's fine, not a big problem. And now we are back to scene renderer. And we need to, what do we need to do? We need to continue on with this. So, and let's give this a little compile. I'm sure it will compile. Actually, I don't know if it will, but I think it should. It's a big file. All right, good, it compiles. So, let's begin by maybe getting the renderer 2D to work, which might sound silly. But the reason why is because I'm a bit scared, if I'm being honest, of materials and descriptor sets and all of that stuff. Because I think that that's going to be a significant amount of work and also that needs a bit of designing, right? Which is fine. I'm happy to do that. It'll be fun, but it'll also be a lot of work. So I'm kind of, deferring it a little bit. So what I think might be nice is if we go through and we get the 2D renderer to actually work, right? And not even that, but like I'd like to run through this code, meaning like, and I don't know how any of this is going to work. I don't think it is at the moment, because you can see it goes to the descriptor set manager and then set input and whatever else. And, bake, for example, like what's that going to do? Yeah, nothing. Okay, fine. So I want to basically run through this code in the runtime and see if it runs. So what we'll do is if running through these render passes is going to be silly, and obviously all these things like renderer, render mesh with material, like that's all commented out. And we need to redo that whole render API. But the 2D rendering is what I have faith in, right? And also we have this clear pass, which, at the moment does a begin render pass, with an explicit clear. So we need to make sure that we put in explicit, yeah, so we might make this work. So let's do that maybe. Let's deliberately do a clear pass, which we can do here, right? So if this is resources created or whatever, let's put a little false in here. My caps lock key was annoying. If false, then we won't do any of this. We're just gonna try and do this. We'll begin a command buffer, we'll clear, we'll end, we'll submit, and then that should hopefully be enough. I don't know what update statistics, that's just CPU stuff, right? Yeah. Although it does do get execution time from the command buffer, which at the moment returns 0, which is fine. So we'll just go through, do that clear pass, which we have to make begin and end render pass work. And obviously it's going into an actual pass, including the composite pass, which is that final render pass image. So if we can get this working, then that's good. And obviously I'll make it clear it to like a special color, although the color is actually in the pass. So in terms of this, let's actually make this work now, because this should be super simple. I mean, it's funny because this looks huge. I guess begin render pass does more than just begin, like VK begin render pass. It also like binds the pipeline, and it potentially does a clear and even binds descriptor sets. Oh yeah, for the actual, yeah, that makes sense. That's okay. We're gonna do our version. So basically, if we have a look at I'm GUI renderer, and we have a look, so this is the, yeah, this is the clear that I saw. Are we on the render thread here? No, probably not, right? Because we begin by submitting to the render thread. So let's do that. Surely we have NVRHI here, yeah, so what's the problem? Oh, utils. Render command buffer, get active. Okay. Whoa. Yeah, that's a bit interesting, isn't it? What did we used to do? Get active command buffer. I'm just wondering, because that might not work, because if we're on the render thread and we begin that not on the render thread. Oh, but it submits it, right? Or does it not? Hang on. Oh, it does. It does. Guys, it's fine. Because begin doesn't begin, it submits it. Okay, good. Because we just have to make sure that my worry was that since that this is basically deferred / runs on a different thread, if we try and get active, then obviously that is only active between begin and end, otherwise it's null. And so that wouldn't work if we were not doing it on the render thread, but we are, so it's fine. Okay, so we need looks like we need a frame buffer, which I think would be inside the render pass, or at least it will be to some extent. And then we obviously have a clear color, which should be in the render pass specification as well, right? Or is it not? Where do we set this clear color? Let's have a look at, it might be in the pipeline actually. Pipeline? Really? Okay, we gotta have a look at where that's stored. Because it's stored somewhere. In the frame buffer spec, which is in target frame buffer. And that's probably how we also pull out the frame buffer. Because yeah, frame buffers. We never did that, did we? Oh, we did somehow. Oh, awesome. Okay, well apparently frame buffers exist. That's nice. There's a lot to get through though. Get clear values. Oh, and we already ported that, didn't we? So it's a clear value, which has a clear color value. Which is hopefully that. That's a long line. Yeah, we're also gonna have to go through and make sure that so clear color value is gonna have 4 floats, right? But this one's a color. And what is a color? The same thing. Wonder why it doesn't take in that. If you're clearing, I feel like it should take in that. But there's no conversion, is there? I mean, it's in the same layout, obviously, but that's a bit annoying. Because it wants them all specified manually. That's annoying. And then, yeah, the frame buffer. So let's grab the frame buffer. That will make this easier. And we also can do get handle to get the frame buffer. And then yeah, for the clear values, this is annoying. So, I mean, we obviously have to go through and clear every attachment. So, attachment index, yeah. So, we'd go through, like in the frame buffer, how do we get, so there's just color attachment count and has depth attachment, right? And then I guess we can, so I think we can have up to, is it 5 attachments, 4 color plus a depth? At least that's, I don't know what we support in Hazel, but I don't know if, yeah, anyway. So let's just do that then. So we'll do NVRHI color, and then we'll do 5 as the max element. Although the depth one actually, whatever. Let's go through, it's probably not gonna be that, but anyway, frame buffer dot get color attachment count, because they'll each have a clear color. That's the size T. And then we'll do clear colors dot push back. Clear values 0, and then this is sorry, clear values I, and then this is where we have to build a color out of it. So hopefully that's in the right order. Okay, so now we have our clear colors. On the other hand, we could just do the clear immediately. That way we don't have to store it. That's probably better. So we'll just do this, and then we'll immediately pass it in. And then I guess if the frame buffer has depth attachment, then we will clear depth stencil attachment. Oh yeah, and this is I as well for the index of the color attachment. And then this will be clear values has depth in it, right? Okay, so, well, I mean, it'll be the last one, so clear values dot size -1 to get the last one. Actually, what is clear values? A vector. We could do dot back or something, but whatever. Oh, and then we have to convert it, don't we? What does this even want? Oh, it's just a uint 32t. Oh no, float depth and yeah, uint 32t. So like that. Cool. Okay, so now we're doing that explicit clear. We haven't actually begun the render pass yet though. So if we go back to our reference, which was the I'm good renderer, which we know works. How does it begin the draw? Or has that already begun somehow? Does it even? Okay. Yeah, ref is kind of shared pointer, except it's intrusive. It's an intrusive reference counting system. So the reference count is actually stored inside the object rather than outside, and that's important so that we can do things like we just did. Things like, where's my storage buffer? Like this, where we can make a new ref out of the current instance and then submit that into the render thread. So that's very important. Okay, yeah, I was trying to figure out how we start a render pass, but I think we don't. Like, I think NVRHI kind of does that lazily, meaning that like, when we actually do like draw indexed or whatever, where I don't know that does that. Okay, so it's not in draw indexed. I think it's in set graphics state. So if we have a look at this, set graphics state. So yeah, so that I think you can see will potentially begin a render pass if there's no currently bound frame buffer. If there is, it will keep going into that, I guess. But if the state changes, then it will actually end the render pass. So it kind of does. It does begin and end render pass automatically when you set the graphics state, which makes sense because it's fine that it does that, by the way, because you can see that what we used to do inside begin render pass. So this is begin render pass where we've been. What we used to do is, yes, we used to obviously explicitly do vk command begin render pass, but then we also did bind pipeline, right? And bind pipeline is set graphics state. So it all happens within the same function, so it's fine that it's not. We just have to make sure we do set graphics state. It's fine that it's not explicit or whatever. And I think we can even do this first, and then we can set graphics state, which is good. So we need to get the current command buffer or whatever, so that we can set the graphics state. Command list handle. So this is obviously coming from here. And then draw state is something we set here, which is important because we need to set everything. Now the thing is, it's got stuff like index buffers and whatever else that this is interesting because we can't set that yet. But I guess it's fine to reset that every time we render a mesh. It's just that, because it only does stuff like this if it changes, as you can see. So none of this will happen. It's just that obviously the index buffer is going to change, at which point it will rebind the index buffer. So it's fine. It's a bit weird. It might seem a bit weird. And also I feel like the current graphic state then needs to be shared, which it's not at the moment. So that actually might need to be something that we store inside a render command buffer, which is a bit of a new design. But that's so that we can pass, because it makes sense because it is actually the active state. Like when you bind something in Vulkan, like if I bind a pipeline or a vertex buffer or an index buffer, I'm binding it to a command buffer, and it's effectively global state, but within that command buffer. So it's not obviously global across the app, but it is global within that command buffer. So I guess it would make sense for us to actually have a graphic state or just a current graphic state or whatever inside our render command buffer, right? Because that's kind of what they're for anyway. So I think we'll probably end up having to do that. But for now, let's just go back here and yeah, and it'll be this actual state, right? Because we're about to define a state if we go into render and I just have a look at where we start creating this draw state. So here it is. So we'll effectively have a draw state. I don't know what it's called. Let's call it a graphics state. And we don't need, I mean, we're gonna need some things like, yeah, the frame buffer. Will be frame buffer get handle. Pipeline, pipeline's inside the render pass in Hazel, right? It would be, yeah, because we set it here, so it's this basically. No, we might as well get the pipeline first. Because then we can use it here. Okay, and then viewport and scissor. So how do we deal with that? So here's the viewport and here's the scissor. So scissor is this. I'll just leave it up here for reference. And then viewport. Depends on if the swap chain, because then we flip it. We do some flippy things. But otherwise it's width and height, which is frame buffer. Get width and height. Are these uint 32Ts, not floats? They might need to be floats. We'll see. Yeah, so this is easy because this is just, yeah, here they're floats, I think. And then for scissor, these are static vectors, which are nice. Okay, and then for scissor, we set scissor manually, but it's just it's NVRHI. Correct. And they're all integers, or yes. So we can just actually set width and height. Cool. Let's clean this up a little bit. So we'll set the pipeline and the frame buffer up here. We'll cast these to floats immediately since they're never needed as integers. And we'll change the name. I'll just add some assets, but we'll see. Okay, and then, so we're setting that stuff up. The pipeline, obviously. I think that's it. Well, the binding sets. So we need to set the appropriate binding set for, like, basically the render pass level binding sets. So the descriptor set, what's it called? The render pass level descriptor sets. So they're basically descriptor sets that stay bound for the entire render pass, not per like object or per draw call. Cherno, have you ever studied C++ spec? No, I have not. Yeah. Cool stream. We'll be back to watch later. Thanks, Boom Trout. Okay, so that's kind of it. So obviously we need to do the descriptor sets. There's also like this dynamic line width, which I guess we should do, but whatever. Explicit clear we're doing now. This is just the scissor and viewport stuff, which we might need to flip. So yeah, and then there's also some debug label. I'll leave this stuff for now. What do we need frame index for though? Nothing. Okay, cool. For the descriptor sets, sure. Yeah, and so we can set the graphic state. So the benefit of doing this is in begin render pass, that basically eats the cost of, you know, beginning the render pass, binding the pipeline, doing all of that stuff. So set graphic state still does that, and we can do that again per draw call, but it will do way less. Okay, cool. So yeah, so we don't have any descriptors or anything. It's just, we're just doing a clear here. In fact, none of this has to happen obviously for a clear, but regardless, it's still trying to do some stuff. Okay, so next up we will let's see, end render pass. The thing is, there is no end render pass, is there? It ends the render pass when you begin a new one, basically. I guess you can, no, that doesn't make sense. You can pass a null frame buffer to really end the render pass if you really want to. But heck, does that really mean, but we have to end the render pass. We can't just begin a new one. Like, as in, that has to happen somehow. So let's have a look at how that happens. I'm GUI renderer. So we just do draw indexed. Obviously, we set the graphic state lots of times here because we need to update the binding set with new textures for GUI. And then we do, yeah, we just do end and submit. Maybe by closing the command buffer, maybe consolidate. That's what I expect will happen. If we look at Vulkan command list and close, it's probably going to end the render pass somewhere. Yeah, oh, there it is. Literally the first thing it does is end render pass. Cool. All right. So obviously we won't do that. So basically end render pass does nothing as far as I'm aware. I mean, we can add a marker though, because it's supposed to add a marker, but we'll do markers later. I just want to get this at least working and then we'll do markers. So we'll do nothing for end render pass. Cool. Okay, well, believe it or not, guys, I think we are ready to maybe see a clear color in the viewport. Because we should now be doing this, and that should be somewhat successful. Oh, I need to make sure that I only do the... So the clear, we only do if explicit clear is given. Otherwise, we don't actually do a clear. Because obviously sometimes you don't want to do a clear, otherwise you'll lose all your data that you might want to retain. So that's the explicit clear part of it. All right. Yeah, pretty exciting. So if we go back to the editor layer, let's make that code path work. So at the moment it's creating a null. So let's just compile the whole engine and run it without going through scene renderer. So at the moment you can see it's creating a blank scene renderer without the current scene, which means that it's not going to go through the code path that we've been working on just yet. But then when I uncomment this line, it will. And that's where we'll be able to see if we manage to get anything working. Okay, I got lots of issues. It's just buffer. Vulkan storage buffer, I thought I deleted. Oh no, it was Vulkan storage buffer said that I deleted. Yeah, this can go away. Still compiling. I'll let it finish. It's already up to Hazelnut. wonder if that will, if there's anything that was explicitly using that stuff. Yeah, like descriptor set manager. He's gonna be upset. Does the Vulkan uniform buffer still exist? Yeah, we should get rid of those two as well. We might need to spend some time getting this compiling, actually. Let's just try and build descriptor set manager. Oh, well that worked, so maybe not. Okay, storage buffer needs NVRHI. Compute pass needs all of this stuff. I don't think it actually does. They're just old includes. Wow, look at this. This is a big stack. Texture 2D create, so we'll see what that'll probably still happen, yeah. Actually two things. Yeah, that. And then create spec and pixels. So we might have changed this. Spec and yeah, so pixels now is a buffer. And it's explicit, which means it needs a size. What is the size? Does it even care about the size? I mean, the size is going to be what is it for? It's gonna be 16 bytes times the size, but times width and height. But I'm just wondering if it cares. Where's the constructor? Because if we pass in a buffer data, create from buffer, I don't know if it actually uses the size. No, it doesn't. It kind of creates its own size. Okay, in that case, I don't know if it's worth using a buffer. Like, we might just use a pointer. Because otherwise, the equivalent would be a buffer 0, which is a bit odd. So I don't know. Because it doesn't need it. It's got its own ideas as to what the size should be, but it'd be nice because then you could assert the size or whatever. And also create cached atlas or whatever, like wherever that comes from, surely it knows the size of the data. Pixels, right? Because it has to allocate enough memory for it. Read bytes. Yeah, so it'll have, and pixels also has the header or something. It's, oh, it's just plus that, so it's offsetting the buffer. Okay, yeah, so did that compile? Still upset. Oh, this is a similar thing. Yeah, I might change this API a bit. I mean, we're still in font, to be honest. So this is font specific. But yeah. Yeah, I think if we can get Maybe for today, I'll try and get renderer 2D working. How about that? And with fonts as well, because it can render text and world space and stuff. So if that works, I think that'll be good. Okay, so this runs. Let's now go back and activate our new code path. So now I'm expecting some crashes. Is my mic kind of quiet today, or is it fine? I just realized I have it lower than usual. How's this? Is this better? Testing, 1, 2, 3. Quiet live stream potentially. But you guys didn't seem to mind. Okay, so yeah, so we can't do that apparently. Well, yeah, the whole validate function. What does validate currently return? Is it just hard coded to return false? Well, actually, it seems okay. And bake does nothing. But validate kind of looks like it does the right thing, in a way. Oh, can you take me to the right thing? Okay, because look, it goes through and it kind of sets some stuff and it only returns true if something's... Yeah, no input resources for set 1 apparently. But that's weird because... Aren't these in set 1 probably? Ooh, that is wrong apparently. But don't we make that? Uniform buffer set create. That's a bit strange. That should have worked. Very weird. Let's run this in debug. Oh, whoa. What the heck? Oh. Gotta make sure that you compile and debug before you commit. If you change stuff like this. All right, basically rebuilding everything. All right, so we've got debug build now. Very slow debug build, good times. Yeah, so what is with... Oh, that is fine. Okay, that was just a release mode weirdness thing. So I kind of want to... let's go through this and validate and see what doesn't work. Again, it's probably pointless to look at this. Oh, maybe this is just null or something. No, it's not. Oh, yeah, so it's... Apparently it's saying... Oh, we have no input resources. Yeah, so I think it's okay. I think we just get this to return true for now. And then, yeah, we don't worry about anything else because this is obviously a very temporary thing, but it's because this class doesn't exist at the moment, doesn't do anything. So therefore we shouldn't be reporting that it's invalid. Same with this, like, there's no declaration because things are weird. But why is it specifically that failed? We should probably have that. Like, as in these worked. So this is null. Huh. Oh, but there's no input declarations. So how could it find that? Maybe the other ones didn't have asserts. Oh, they didn't. Just this one has a verify. Okay, that's a little strange. Again, we're going to rewrite this class, so I don't care. Our camera seems to be working, by the way. It's been ages since it didn't work. Okay, so we're trying to resize a frame buffer. Oh, we might need to clear like some stuff if we resize. I don't know if we did that. Oh no, these are all unique. So wait, so what happened? NVRHI static vector might be out of range or something. Oh, because this is 0 and we're trying to access something. But it's set to that. Oh, because we haven't reserved it. So what we need to do is, where is this stored in? So if we know the color attachment count, which we might, or we might not. This I don't think we use. Oh, but to be honest, we can just do pushback, can't we? It's a static vector anyway. So instead of doing this, or do we have to? No, I think we can just do dot in place back and get the reference to it, right? That should work. Why are you writing NVRHI backend when you have Vulkan? Because Vulkan alone is not enough. Like, it's not good enough for everything, right? Like, first of all, like, Molten VK is not ideal. It's a translation layer on Mac. DirectX 12 is still the preferred API to use on Windows. And also, if you want to ship like on an Xbox, you need to use DirectX 12. The Nintendo Switch supports Vulkan, but again, through a translation layer, it's not native. And PlayStation doesn't support that at all. So for the future, like, I'd like to have a more robust backend for Hazel so that we could actually use any render API with it, right? But also it consolidates our, because Vulkan is coming out with new features, new specifications, you need to adhere to that. So by me just using NVRHI, it's like I'm outsourcing that whole renderer backend system to NVIDIA, right? And then they can work on that. They are obviously aware of what happens in the graphics industry. And then I can just use that. So it actually makes Hazel's backend renderer and like things like state tracking and all of that stuff way more robust, which is good. So even if we just use Vulkan, it's still going to actually have a benefit. And then also it handles like device capabilities better. So we at the moment don't even support Intel GPUs really. Like, I think if we disable some features, it works, but because NVRHI is written in a way that has been tested across various, much more hardware than I've personally tested on, it kind of functions better overall across even just different hardware, but still like Vulkan. So it's quite a big advantage, to be honest. Okay. Oh, we're in IMGUI render. I begin timer query. Oh, oh, cool. Because we have assets here, and we weren't really running debug before. So it's the query has been started already, and we're beginning another one. Yeah, I think we knew this. Although that's weird, because that means we've called RT begin twice, or like begin on the render command buffer twice, doesn't it? Why would we have done that? Because begin timer query only happens once, and then when we do end, we end it. So have we forgotten an end? Surely not. Oh, you know what it might know? It shouldn't be that. I was gonna say maybe we need, oh, but also look, we have 3 of these. And then we end it here before we do that. That's a bit weird. That's basically implying that we... Where does query started get set to true? And false. And why does end timer query set started to true? What? This is a bit strange. So when we do get timer query, it sets it to false. And reset. Oh, I think we might have to call a reset. What? Take me here. It's on the device. I think. Why would that be on the device? Because then that needs to do begin. I don't know how you're supposed to use this, to be completely honest. And that ends the render pass. What? That can't be right. Why does this end the render pass? That's really weird. I think maybe we're not going to do queries for now because I need to look at how on earth this works. So let's, we can still do markers, we just won't do timer queries. But NVRHI does only support Vulkan DirectX, there's no support for WebGPU, Metal, or PlayStation. Yeah, I'll add that. It's fine. I would have had to have added it anyway to Hazel, and the fact that they've clearly defined it, and like it's a well-designed abstraction layer, means all I have to do is just add another backend, right? So it's not that much work compared to if I have to by myself design a system that supports everything, you know what I mean? From the ground up, and also maintain all of them. Like, it's good to have NVIDIA in control of a common API, basically. Okay, look, it's running. That's awesome. So what that means is that, let's switch back to release mode. What that means is that we can now hopefully see an image in the viewport. So at the moment it was gray, and that's because, oh, well, actually we should be seeing something there. I don't know if we're doing the composite pass. We should be. But maybe I can set it to like pink or something. So inside, currently inside, I guess, what was it? The clear pass? Yeah, so we do go through the composite pass and we should be clearing it. And we should be executing it. And so the get final pass image should be getting it from the composite pass. Unless resources created is false. But I think resource created should be true because you can see we submit that. So we should be actually getting that output. I just don't know. It does seem weird that it was gray because it should have been probably black. But if we have a look at the composite pass, this-ish, where does this get created? It's got to be like up here, right? Yeah. When we create the frame buffer, here it is. So the clear color for that, oh, the clear color actually isn't, the clear color is like red, basically. So we aren't seeing that, which is upsetting. So let's go back and, yeah, I would have expected to see that. I'm going to switch back to debug and we'll run it again. I'll put some breakpoints in, make sure that we're first of all clearing it to the right color, but also that we are, actually running through the right things and doing our image stuff. So if we have a look at viewport, this is it being drawn. So again, basically this should all be red, right? So if we have a look at, I guess we can put a breakpoint here. Okay, this isn't being drawn. So that means that our final image is actually null, which is weird because resources created. Oh, resource created is false. But how? It's set to true here. Wait, do we like return from this? Sorry guys, give me a sec. Okay, sorry about that, guys. I'm back. Okay, so yeah, it makes sense, but NVIDIA will probably never make support for metal on PlayStation though. Sure. I'm personally using WebGPU because it does support Vulkan DirectX Metal, and I'm using it for GPU UI. Yeah, I mean, there were a few different choices. I think NVRHI suited my needs more, and because we are primarily shipping on Windows, on desktop platforms anyway, having, you know, strong support for Vulkan in DirectX 12 was very important for me. And, you know, some of those other APIs like web might not be something we have scope for anyway at the moment. Okay, cool. So let's have a look at why that might be null, because I'm a little bit confused as to why resources created as null, unless we never get down to here. Oh, but that's resources created GPU actually. Oh, so begin scene is what sets this to true. Okay, that's kind of annoying. Okay, let's just do this for now. Just to see if we get that, but otherwise, obviously, it does expect that we render a frame of our scene first. But actually, if we don't do begin scene, we'll probably won't do flush either. So maybe I should do begin scene. But then that will go through and try and render everything, which might not work. So I think we'll still see nothing here because I don't think flush runs. Yeah. Okay, so should we try and do begin scene and stuff? I guess we have to make sure that code path eventually works, right? So if we go to on update, I'll get rid of the return here. And then, yeah, I guess we'll see. This now will actually render the scene because it will do editor scene on render editor. Which will do set scene and begin scene and go through all the mesh. Anyway, this is probably going to crash because this is now doing a lot of code, like a lot of stuff. Now it's actually loading assets and probably doing stuff it wasn't before. Oh, and here we go. Okay, so now we're actually trying to do renderer 2D things. So sure, let's disable that for now. And then, yeah, we're going to try and work on render 2D today and get that up and running. And then next stream, we'll probably start just working on the... Yeah, I think next stream, the biggest thing will be rewriting. Well, either implementing the descriptor set manager in a new way or also actually filling in all the render commands that we need. That's still going here. Because we're doing it here. So on render 2D, we'll return from... We could just probably figure this out though. Oh well. Hey, we did it. A red screen. So that is in fact our buffer. This isn't that amazing, to be honest. It looks nice, but it's not that amazing because, yeah, it's more impressive that we're not crashing. But obviously rendering the actual geometry is going to be a lot more work. Or maybe not, who knows. So 2D rendering, let's do it. Who's excited? Everyone's favorite. Because it's easier. I wouldn't say it's easy necessarily. Depends on how complex of a job you're doing. But let's go to render 2D inside here. Get rid of our return. That's from the editor. And so if we go to render a 2D, I think we ended up disabling quite a lot of stuff. Like for example, get target render pass returns null. We disabled like all of this. So we're gonna uncomment that or undefine, get rid of it. Swap chain target, we're not going to do anymore. We'll just do a normal render command buffer. Yeah, 0 and render 2D. Yeah, we got the uniform buffers now work. Frames in flight, sure. Yeah, I mean, look, all of this compiles somehow, so that's good. We've got all of our passes as well. So what needs to happen really? So begin scene. Yeah, some shaders or whatever. We set data for uniform buffers, pretty standard. This is exciting. This is going to be our first real rendering that actually hits shaders outside of IMGUI. Circles was to do apparently, but we can get back to that. Most of the stuff is, yeah, here. So let's try that. And then if I go to scene renderer, we also had, actually not scene renderer, scene.cpp. We also got rid of 2D rendering here. So now we are kind of trying to do 2D rendering. So let's see how this works. I actually don't think it will, or at least it won't look right, because I don't know how we're setting resources, meaning we would have to be setting images, like textures, into the shader, because a lot of what we draw, like fonts, for example, and everything, are textures. So I don't know how that works for the simple case of 2D rendering. Because for the 3D rendering, we know we need that descriptor set manager, which I basically removed. Which is more, I'm probably going to rename it to like resource manager or render resource manager or something. Oh, well, look, we're not crashing somehow. So what, we are doing 2D rendering here apparently? Is that true? Because if it is, I don't see it. Or are we not because I'm clearing it? No, but we should be doing it on top, right? So for example, in the editor layer, run render 2D. Yeah, so look, we seem to be doing that stuff. So there's icons and other stuff should be rendering. I don't know if icons will work, but if we try to do bounding boxes or like physics colliders might be 3D. But bounding boxes for all entities, like we're not seeing anything. We should be seeing it composited on top, I would imagine. Unless the clear pass also clears it, but no, this is already happening in the final image, I think, and especially actually for the editor layer. So oh wait, or was bounding boxes not here? No, they are here. So for example this, so we're hitting this stuff. That's for submeshes. I don't even know how to do that. Oh, you need to select, oh, apparently you do need to select entities for that. Oh, so it should be doing them for everything. It should be drawing AABBs. So draw a line, like how does that work? It adds it to the buffer, and then I'm guessing we do a flush. Oh. What? It's gone. The heck? What do you mean it's gone? Why would I just flat out delete that? Oh, but look, here's render text. Oh, because end scene does it, that's why. So we're going through, so we got no quads to render. Do we have any text to render? No, apparently. But we should have lines, right? Yeah, we've got like, not much lines. Oh, right. So I think render geometry probably does nothing. So much stuff. Yeah, render geometry does nothing. Well, yeah, that makes sense. And for the text and everything, I guess that would also do nothing. So render geometry. So because it's the line pass, right? It probably specifies that it wants to render lines in the topology. So that should work, right? Like we should have lines here. Yeah, it's a line list apparently in NVRHI. So we really just need to bring back render geometry. So it used to be an sRender API, but it doesn't need to be there anymore. It should just be here. And yeah, we do have a material and stuff that I guess it does still use materials and whatever. So if we go into Vulkan renderer, which is where it used to be, and we look at the render geometry just so we can have a reference as to what this used to do. This is what it used to do. Yeah, so I think we can just do a subset of that for now. Yeah, so this is where that graphic state is going to come in, right? So we're going to need to, when we do set graphic state, we're going to have to, I don't really see how else to do that here, but we're going to have to store the state within the render command buffer, which, you know, doesn't seem too bad based on the limited thought I've given it. So if we just store the graphic state, and then we will do a set graphic state. And I also want to do get graphic state in both a const and non-const flavor. So we can have, that way we can easily write more to it. I guess we can implement that here. And then the idea is, so we could just do graphic state equals get graphic state. That way we don't need to set it at the end. Right. That's not const, right? No. Oh, it is, because this is immutable. Okay, yeah, and then, so command list, so, right, because I would get that to set it. I guess that's okay. So we just need to make sure, I guess we would just need to make sure that we actually set it like so. And that would kind of make sure, in this case, it's almost redundant because we're the ones creating it. So we could actually just do that here. It's not going to matter too much. But yeah, this would have to be a bit different, because basically it would do this, but then it would also have to do, so that would be a device thing. That would be a render thread thing. Because it would basically do what we did here, which was it actually says it into the command list, not the device. Yeah, but still. Okay. Yeah, so once that gets set, though, but the thing is, we might want it to immediately have access to it, but I guess it doesn't matter. Because yeah, this could introduce some inconsistencies, but Okay, this is what I'm gonna do. I'm gonna do something a bit different. I'm gonna separate the data from the actual action. So set graphic state and get graphic state, I'll leave as is, just because I want the data, that you might want to preset the data without hitting the device first. So this will just apply the graphic state like so. It'll be very simple. But then I'm going to make a function called commit graphic state, and that's what's going to hit the device, and that has to be called from the render thread. So that will do this. So I'm kind of separating these two things, right? And that will do graphic state. And so the idea is that you can not get rid of this because it's got a definition in the header. So we don't need to, so what we'll do is we'll get from the render command buffer, we'll get the graphic state like this as a reference, write data into it, and then just call commit. And that way we can do this from either thread, and we can, obviously you'd want to somewhat synchronize that, but like you can do it ahead of time if you need to, and just like whatever. But then this is the call that actually commits it, meaning it actually hits Vulkan and stuff. All right, so okay. So if we go to now that we have that state, if we go back to the renderer and we go to like geometry, render geometry, which is where we are. Now that we have that state, I mean, we have pipeline and everything here. And I guess we need to make sure that that's started, but yeah, maybe it doesn't. Have you ever been interested in making games, not engines? Yeah, I mean, I'm interested in making games. I like engines more overall, but I do want to make a game one day, or several games. But for me, like there would be more like maybe like story-driven, yeah, story-based games or something, right? Like it'd be kind of like, because I was really into filmmaking when I was younger, and I kind of want to tell potential stories, but in the medium of games. So there would be more like that, not like arcadey mobile games or whatever, you know. Okay, so if we have a look at this, so what we need to do here is basically we need to get the graphic state and write some stuff into it. So so that would look like this. And the stuff we need to do is basically do like, see, I don't want to do add vertex buffer, but we'll just do vertex buffers, which is that, what is that? That's a static vector. I guess we could do resize 1. That would, because that would work all the time, and then just basically set vertex buffer get handle. What does this actually want? Vertex buffer binding. So it wants a slot and an offset. How did we do this before? We might have to do add. I guess we can look at GUI renderer. Well, we kind of create a new draw state every time here. But yeah, we just do slot. I guess we just do that. I wonder if there's a better way to do this. Maybe just like that, if it has an initializer list. Yeah, that's probably better, right? And this just makes more sense than doing it all in one line, I think. I'm gonna have to write it out. It just looks stupid when it says VP. I like to be pretty explicit and verbose in my naming, to be honest. Okay, so with index buffers, we don't really have a slot. So I guess that makes things easier, but we do have a format. And the format is basically always, I think Hazel only ever supports this. But we can have a look, because if we have a look at the index buffer class, I'm pretty sure though that, well, yeah, we don't have any distinctions, so I think we only support that. It's hard to tell though, because it's like we're just taking a buffer, so it could be anything, but it's 32-bit only indices as far as I'm aware. Oh, that's probably not an array. How's this? Should I move it like that? I guess that's alright. Maybe I'll just keep it grouped. Is that better? Kind of setting it at the end. Sure. Okay. So we got the index buffer. We got that. What else did we have in Vulkan renderer? Descriptor sets, which we're kind of ignoring for now. Push constants, I guess, for the transform. And for possible uniform buffer, but that's from the material. So the vertex shader is going to need the transform. So for the render geometry call, I think it expects. So if we have a look at renderer 2D line, that expects the transform in the push constant. Yeah. So we have to basically, make sure that, yeah, that we do this. So if we have a look at, again, I'm GUI renderer, because we do some push constant stuff here. How do we do that? It'll be set push constants. Oh, that goes right into the command buffer, sure. And then we do have the transform here, so we'll just do transform. Now, this doesn't really seem to care about offsets somehow. Weirdly. How does it know the push constant visibility and stuff? I don't know. Current pipeline, I mean, it's got the layout, but like the offset is hard coded at 0. That's a bit weird. I guess it expects all of them to be set at once. So this might not work. We might have to modify some of this NVRHI stuff, but we'll see. Maybe not. Maybe we can figure out a way to do it without that. Okay. Yeah, and then we can just do the draw call with the draw arguments. So let's grab the draw arguments and the draw call. Okay. And let's have a look at how we got everything from Vulkan renderer. So, I mean, yeah, so we have index count. That's actually passed in. We don't have vertex count. I don't know why we need a vertex count, really. Start index location and everything is just 0 for this case. This we can call draw args, surely. Yeah, vertex count. Why is it not? Is that what it, like, I guess that should just be index count. Because it's the same thing, kind of. We're drawing that many vertices, you know. And that should be it. So yeah, we should kind of render something now, maybe. Like lines should work. Assuming that we begin the render pass and it obviously is lines. So, I don't know, let's have a look and see if we get any lines rendering in 3D space. Okay, while that's compiling, I'm gonna BRB. Okay, I'm back. What do we got here? Oh, push constants didn't work. Why? Something about an access violation reading 0. What was 0? What was 0? Do we not have an active render pass or something? It's possible to see here. Okay. I wonder what happened here. It would have had the layout already. It's a bit weird. It doesn't say in the validation, does it? No. This validation has been like useless so far. Huh. Actually, well, the reason why this happened earlier, like, because we had something similar with push constants back in GUI renderer days, and that was because I think we didn't have this binding for the push constants in the binding layout description in our pipeline, right? So let's double check that we have that here. Oh, we don't have any binding layouts here. Okay, that's not good. What? Oh no, but look, pipeline binding layouts. Oh, so they're kind of coming from the shader? Because binding layout... Yeah, binding layouts. So that is that. Get all descriptor set layouts. But how do they get set? They're probably empty. Resize 0. That's release. Reflection data. Does it do push constants though? Maybe it doesn't do push constants at the moment because it needs to. How do we even do push constants in here? It just sets this in any order, I guess. But does it even do create binding layout? Yes, it does. So yeah, so here we need to make sure we don't set push constants, as you can see. And visibility also might need to be adjusted. Okay, so with push constants, how do we deal with them? We don't. Okay, so I guess we just need to make sure that, and what function is this? Create descriptors. I kind of want to refactor this, but I think we can probably just go through the push constant ranges, because we go through reflection data shaded descriptor sets. So we need to also, whoops, cancel. What's the point of having a cancel button if you can't cancel? Can't type push constant ranges for that set, right? Why are these not const? So that's a vector. So that would just be a single push constant range. So I'm guessing we can just do that here if we want. So binding layout, description, I guess dot bindings, dot pushback. And then we would go here. And then we would grab this. We do a push constant 0, slot 0 for that, and push constant ranges. It just needs the size. Oh, well actually offset, it doesn't do offset though. I don't understand how they don't do offset. It's like important, unless slot is somehow tied with offset for that. I don't know, it's weird. Let's just do size for now. And that's obviously if this is not 0. Do we need to check that first, or does that always exist? 'Cause that's a vector. I guess we do need to check it. Yeah, we do. Or would there always be one per set? I don't really get that. When we read it. But what about the shader compiler? Because the shader compiler ultimately sets that, right? So what does it do? Where does it set it? That's not... What is it? What? That's odd. And place back. Oh, right, here it is. Reflection data push constant ranges and place back. So it only does that, I guess, if it is there. That's weird. Oh, because this isn't tied to a set. I keep thinking, yeah, because we're inside, that's a bit of a mistake. Because we're inside, this is shader descriptor sets, right? So this is per set. And we have to create a binding layout per set, I expect. That's why, I guess, it's weird that push constant ranges. This doesn't map to a set though, like shader descriptor sets does. So how would we set that? We just need to make sure it's in what, the first set or something. Or at least once for a binding layout. I don't know. But yeah, I think we just do this outside of this basically. But it needs to make it into the first binding layout, doesn't it? Okay, fine. Let's do this for now. I don't know. We're going to have to test this out and maybe I will learn more. But if set equals 0, then we'll do it. We'll do it only for the first time, basically. And this will be... and this is the weird thing. Like, there might be multiple push constants, but maybe we just increment this in that case. Maybe that's how it works. That would make sense. So if we go through, so it's one of these guys. Again, no clue if this will work. But if we try this, maybe we'll get somewhere. I don't know. It's weird because again, the push constants are not in. It's not in. Yeah, they're not in descriptor sets. That's not how it works. So I'm not really sure how it maps to this, but whatever. Let's try. With that in mind now, it should be in the binding layout. So let's try run this again and we'll see if we get that error or not. Where's the shader? It's gone. Because the thing is, if we have multiple ones, like you can have offsets. Like for example, I'm pretty sure our PBR shaders do have offsets, right? So, oh, actually not anymore because we don't have push constants. But we do use push constants for material values, but they don't have offsets. Interesting. Okay, let's see if this crashes or works. No clue. Device removed. Uh-oh. Yeah, that just flung crashed. In the worst way possible. Great. Device removed. Yeah, it's a VK device lost. Okay, so that's very bad. We crashed the driver, basically. Wonder if this had something to do with it. Well, I mean, that's the only thing we've changed, so it did, but I'm interested in why that would have happened. So how many of these do we have? 1. Correct. Index is 0. Oh, I should have done index plus plus, but anyway. Push constant range, size 16. Size 16? Oh, this is probably a different shader. What shader is this? This is GUI, I think. Yeah, because we got 2 vectors. Okay, well, yeah, this is supposed to be index plus plus, but that wouldn't have caused that. I don't think. So all we're doing is we're just adding the push constants to here. Or would they apply to every set? Like, should they be in every set? That's also weird. It's just, they're not in sets. So it's a bit weird, isn't it? Yep. I might have to look at the docs. And we'll see if it mentions anything about push constants. Binding layouts and sets. So each binding layout consists of a number of items, blah, blah, blah. Each layout item specifies a resource type and the binding slot. The binding slot directly maps to the slot used in HLSL, such as that. Okay. For push constants, the layout item must also specify the size of the constant data, which it does. Well, that's useless then. That's strange. Because the thing is, this should work. It's just that it's only if we have multiple sets that it might be weird. So oh, well, for one, I didn't call set graphic state, but the begin would have done that. But this basically means that, like, we need to make sure we do. Yeah, so we get the graphic state, we add stuff to it. So now we just need to make sure that we do render command buffer rt commit graphic state. And that has to kind of happen before you do push constants, but we already have one active, so it doesn't really make sense. And if we go back to render a 2D and end, what is it, end scene. This is where, so that's quads, text, lines. That's what we're interested in rendering. Oh, we need to make sure that this works. Set data. It should though. I think it did because we got to this. And then anyway, it does begin render pass, which does all this. Then render geometry. Well, let's have a look at, I'll put a breakpoint in set push constants, but I'm sure we get to there. Actually, yeah, we'll have a look at whether or not we get to there. But yeah, very strange. Very, very strange. So far I think so good. And this works. Oh, we didn't get a device lost. Huh. What did I change exactly? Oh, I just made sure to set the graphic state. Oh, maybe that's why we were getting device lost. It wasn't to do with push constants. It was just because we were calling render geometry. We were calling render geometry with this many indices, but no vertex or index buffer bound because we hadn't committed our graphic state. So maybe that was why. Okay, so begin render pass is trying to do pushback. Yeah, there's too much stuff. So we need to make sure that, yeah, rather than pushback, I think we should just do equals because we only have one viewport and one scissor, so that's much better than pushback. Just reinitialize it. I'll be back in a sec again. Okay, I'm back. Yeah, no errors apparently. So maybe we are rendering lines, but we can't see that because we are not showing bounding boxes. But I can't see the lines anyway. So, and I'm guessing we should be seeing them on here. So we might need to take a look at why that is, but it is kind of specific drawing lines, but still we should be able to see it. I'm guessing. Where is renderer 2D? Just want to make sure we're actually going through this. How many lines are we trying to draw? 2,000 indices. Wow. Okay, well, yeah, we should probably see that. And at identity. Oh. What? Oh, but the how does the camera work? U-view projection. Oh, there's a uniform buffer in set 1 for the camera. Is that being set? How does that work? I think I might know. I think that's probably why it's not working. So the uniform buffer would be this uniform buffer set. that I think I saw, UBS camera. And that's actually set as an input into the render pass, which never happens. So looks like we can't get the 2D rendering working. Well, it's 2D rendering in 3D space. But anyway, we can't get the primitive kind of line rendering and quad rendering and text rendering working until we do fix this whole situation with basically with the descriptor set manager, because we have no way at the moment to get this into the pipeline, because it happens at the render pass level in this case. It can also happen at the material level, which is per draw, versus render pass level, which is per render pass. Like when you begin it, it binds it, and that has to happen here. But obviously at the moment, if we look at that's the text pass, but it doesn't matter. The line pass does the same thing. Where's the line pass? Here's the line pass. The line pass sets the camera input, which tries to go to, because it's a uniform buffer set, it's this line here, set input, and then obviously it at the moment tries to like do this, but it doesn't actually work. So, but also this whole class we need to rethink, and it needs to basically generate, I guess, descriptor sets or binding sets, kind of like we do in IMGUI renderer. So in IMGUI renderer, we basically do that on the fly-ish. We cache it, but we do inside like render. We we do get binding set. And then we basically create one of these using the bindings and whatever. We create the actual binding set from the binding layout. This specifies the actual concrete resources we want to use, and apparently it needs the push constants as well, even though the data's not here for it, just the layout, but whatever. That should be already in the pipeline. It's weird that this has to be here. Maybe it doesn't, I don't know. Because the binding layout contains this exact code, does it not? Weird. Or maybe not. Or maybe we just already have that ahead of time. That's weird. Hang on, let's quickly look at, just to make sure I'm not misunderstanding something. If we go to Vulkan shader. No, this is a binding layout item, but this is a binding set item. So they're different. So this is for binding layouts, which is correct. But for binding, so binding layout item is up here. Yeah, see, we got the exact same code for a binding layout item and binding set layout. This is a bit weird, but whatever. Maybe that's just how it has to be for push constants to map correctly to all the render APIs. And then, yeah, but here we actually set the data. We create a binding set. We can cache it and reuse it, which is what's happening up there if it already exists and the actual resource hasn't changed. But otherwise we create a binding set and then, yeah, we sort that out. So this needs to happen inside the descriptor set manager, which I'm going to rename to like the resource manager, or I don't know, the renderer something manager. I don't know. We'll see. We'll talk about that last time. So anyway, that's it for today. Hope you guys enjoyed the live stream. Don't forget to do everything. So patreon.com/thecherno if you want to help support Hazel and get access to it. Cherno Unplugged is my kind of live stream channel on YouTube where I post all of these streams along with nice AI generated descriptions that have all of the stuff that happened, within the stream. So it's easy to kind of skim through the streams and see what you're interested in. On Discord, there is a channel called Cherno Live, which on my Discord, discord.gg/thecherno. There's a channel called Cherno Live where you can discuss live streams, and also if I'm like running late or something, I usually post a message there so you know what to expect. And yeah, I think that's probably it. So thank you guys for watching. Hope you enjoyed. Friday, I may stream in the evening my time. I'll add it to the Switch schedule as soon as I know if that's happening or not. And thanks, Sculler, for the Discord link. I forgot that was even a thing. I should update that to say discord.gg/thecherno because I've got that URL now and have for like years. But anyway, Friday I might stream, but it'll still be Hazel, but a little bit different. Won't be the renderer. But this we will get back to probably next week. So thank you guys for watching, and hopefully we'll do some longer streams next week. I will see you guys later. Yeah, goodbye.